Hello, welcome to NGSS Physics. We are going to go over momentum today. So grab something to write with, get ready, and let's get started. This is actually lesson 3.1, okay, in case you're wondering. All right, online textbook, CK12, which is in your online syllabus, is chapter 6.1. Okay, to understand momentum, we got to go back and take a look at Newton's first law, which is the law of inertia. This simply states that a body in motion will stay in motion, or a body at rest stays at rest unless an outside force acts on it. Well, with Newton's first law, we're only going to be looking at that body in motion when we talk about momentum. So, the tendency of a moving object to keep moving in the same direction with the same speed, that's inertia. And when it's moving, we're talking about momentum. Okay, momentum is related to both mass and velocity. And that's one of the reasons why the object at rest isn't included, because it has no velocity. Now, how can we calculate momentum? Yeah, we can quantify it with a very simple formula that looks like this. We're going to use small p to represent momentum. The m represents mass, and the v represents velocity. Now, if that's true, then our units for momentum are going to be kilograms times meters per second. And the mass is measured in kilograms, and the velocity is measured in meters per second. Velocity is a vector, which means that since we're using it to calculate momentum, momentum is also a vector. And it's in the direction of the vector for momentum is in the same direction as the vector for velocity. Notice that you've got two variables, mass and velocity, that make up momentum. And they are both directly related to the momentum, which means as mass increases, the momentum increases, or as the velocity increases, the momentum increases. So both of those are in direct relation to the momentum. What if you have a system with a lot of small particles moving in all kinds of different directions? Can you calculate the momentum of that system? And the answer is yes. All you do is add up all the momentums of all the particles. Pretend like that's a balloon right there, and there are little air molecules flying in all kinds of different directions. Some of those particles, the velocity vector, will be in opposing directions. They might cancel out. Um, but overall, if you add them all together, you might see that that balloon has the momentum and is going in a certain direction overall. So yes, you can calculate the momentum of a system. Okay, which one of these has the most momentum? Well, the answer is it depends on the speed. If they were going the exact same speed, I'd probably pick that Mack truck. But what if they weren't going the same speed? Consider this: a bus with a very, very large mass, okay, but maybe has a very, very small velocity. Okay, the mass is going to give it more momentum, but the velocity vector, if that was very small, then it's not as big as the momentum that it could be, as opposed to a bullet with a very, very small mass, but a very large velocity. That can also be a very big momentum. So you can see that both mass and velocity affect momentum, okay, in a direct relationship. And large objects don't necessarily have the larger momentum unless the velocity vector is also large. Okay, the larger that velocity vector is on that bus, the more momentum the bus will have. And the larger the mass vector is on the bullet, okay, the more momentum. Of course, that bullet, if it wasn't moving very fast at all, say you threw it across the room instead of shot it, the velocity vector would be very, very small. And so the momentum would be very, very small because the mass is small. So you need both of those things to get a very giant momentum. Let's take a look at some sample questions. If all three were being pushed at the same speed, which has the greater momentum? Well, let's take a look at the momentum formula. Here it is. Right? The same speed means the velocity is the same for each one of them. So what we really want to do is take a look at the mass. The one with the most mass will have the greatest momentum if they all have the same velocity. That's this one up here, okay? More mass, more momentum if they have the same velocity. Let's take a look at sample question number 2. Which is the momentum of A? Well, we need the momentum formula, just like this. So what is the momentum of A if the speed is 10? Well, we got to get that mass. We got to multiply it by the velocity. And what do we get? 30 times 10, that's 300. And remember, the units are kilograms meters per second. Sample question number 3. Let's say a cannonball has a momentum of 5,600 kilograms meter per second. What is the mass of the cannonball if the velocity is 150 meters per second? Well, again, we got to take a look at the momentum formula. And this time we're solving for mass, so I need to divide out by v on each side. And I see that, oh, the mass is equal to the momentum divided by the velocity. So this is a little formula manipulation going on. So what do I have for my momentum? 5,600. Oops, I got some of those lines that I don't like, but what can I do? And divided by 150 meters per second. Notice the meters per second cancel out, and we're left with kilograms for our answer. So go ahead and plug that into a calculator. 5,600 divided by 150. I think you get something around 37.3 or so. Summary. Momentum is possessed by all moving objects. Okay, they have to be moving to have momentum. And it embodies Newton's first law. A body in motion will stay in motion. Momentum can be calculated using a very simple formula. Thank you for listening. I will see you back in the main classroom.